Find the closest point on the line y is equal to 2x plus 3 that is closest to the origin. For this problem, we are going to want to optimize our distance formula, which can be given as the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's look at our graph to get some information. We know that our second points from the graph, since we're going to the origin, is going to be 0, 0. So this is x2 and y2. But what's our first value of x and what's our first value of y? Well, we will just leave our x like so, and since we're going from the line to the origin, our first point for y is going to be equal to 2x plus 3. There we go. So let's plug this into our distance formula. We'll have x minus 0 squared plus 2x plus 3 minus 0 squared. And now that this expression is in terms of x, we can just call it a function of x. We'll call it d of x. So let's start optimizing our function d of x. We'll do some simplification. So we'll have x squared plus 2x plus 3 squared. This will become x squared plus 4x squared plus 12x plus 9. And from here, we can combine like terms. We'll have 5x squared plus 12x plus 9. Now, we're going to have to differentiate this, but we're going to have to use the chain rule. So to use the chain rule, let's rewrite this to just be in exponent form instead of having the square root. So I'll have 5x squared plus 12x plus 9 to the 1/2 power. This will make visualizing the chain rule a little bit easier. So the derivative of the inside is going to be equal to 10x plus 12, and then we're going to have 2 times the inside just by itself, 5x squared plus 12x plus 9 to the 1/2 power. All right, and we'll simplify this. Our 2's and all these will reduce. We'll have 5x plus 6, and then we're just left with that 5x squared plus 12x plus 9 to the 1/2 power in the denominator. And that's just equal to the derivative of our function d of x. So now, the next step in optimization is to set our derivative equal to 0. So 5x plus 6 all over our denominator is equal to 0. We can then simplify this by multiplying by our denominator. So we're just left with 5x plus 6 is equal to 0. Solving this, we'll get 5x is equal to negative 6, and then x is equal to negative 6/5. That is just our x value. Let's plug it in to our y original of 2x plus 3. Y is going to be equal to 2 times negative 6/5 plus 3. And when we simplify this, we will just get 3/5. So we have the point negative 6/5, 3/5. But we still have to check if this is a minimum, because we are being asked for the closest point to the origin, which is just the minimum distance to the origin. So let's choose two numbers on the left and right of our negative 6/5. We'll choose 0 and negative 2. And if this is a minimum, the left of negative 6/5 should give us a decreasing slope, and to the right should give us an increasing slope. So we'll take our d prime of x, and let's do d prime of negative 2. So we'll have 5 times negative 2 plus 6 all over 5 and negative 2 plus 12 times negative 2. Oh, we gotta forget our square there. Plus 9. All to the 1/2 power. This can be convoluting, so we'll just think about this logically. 5 times negative 2 is negative 10, plus 6 is still going to be a negative number. So that's going to give us a negative number. A negative number on the numerator is always going to give us a negative numerator. So let's check our d prime of 0. So we'll have d prime of 0 is going to be equal to 5 times 0 plus 6 all over, we're not even going to write it out. Because we can see 5 times 0 is going to be equal to 0 plus 6, that's going to give us a positive number. So we go from negative to positive, which is a minimum. So that means our points, negative 6, 5, 3/5, is the closest point from the line to the origin.